You guys able to see my screen?
Yes.
Okay, fine. Let me go to the main window. Okay, so hello, good evening, everyone. I, if I'm think my audio and video both are visible to you and audible to you. So, hello everyone, good evening. Welcome to this Geographic Information System course from NPTEL, week 3. So in the previous 2 weeks, we have discussed different things about the kind of concepts of GIS, and then we have seen the concepts of topology, and then some of the demonstration using GIS software. Then in second week, we have learned about the vector, raster, and team data sets, as well as we have learned about the non-spatial data, nominal, and then other ratio data, nominal data, etc. In the week number 3, the videos are based on the various data compression techniques. We have already learned about the vector data compression, and now we will learn about the raster data compression techniques. So in this lecture, before going to start a quiz, I think, all of you know that we are going to conduct this doubt session class in a 3 different sections. The first section will be a quiz section where we will discuss few questions from week 3 from the last week's videos. Then we will see and explore some of the data sets. And then after we will do some hands-on exercise in QGIS. So that's a plan also for this week. So hello everyone, my name is Hiren Solanki and I'm a PhD scholar at IIT Gandhinagar in Department of Earth Science. And I will be taking your this GIS class problem solving sessions. Okay, so I think what I plan for today is a little bit different from this traditional way, because this week's concepts like we need to revise a lot, because what I seen in the previous 2 class, people have not gone through the videos. So I think we will revisit the previous concepts quickly in 10-15 minutes, and then after we will start this quiz. Before that, if you guys already have any questions, then let me know, or you can think of those questions which we will cover after covering these slides. Okay, so any questions till now? Anyone regarding your assignments and anything else? Okay, yeah. If not, then I think we'll start. So basically in this week, we have learned about the data compression techniques. And when we thought of data compression, like why do we need it, first of all? So can anyone tell me, like, why do we need to compress the data, whether it's in our mobile phone, or like if you go to any government site, they will ask you to upload your photo within 10 kbs or 20 kbs or 100 kbs, and then all of the high resolution image you have to go to some image compressor and then have to compress it. So I mean, why there is a need of doing those kind of stuff? Any idea? You can unmute yourself and you can give me the answer. So we'll try to make this session more interactive.
To
To solve the
first to
storage problem and
Yes,
processing time, reduce the processing time.
yes. So storage issue, another thing is a processing issue. Then what might be the case? How you can think of, like, what will happen? Like, we will upload the data and the data will go to the government storage unit or any sites where we are uploading it. So it will get transmit from one system to another system. So the transmission time also will be high. So what we are doing is we are along with the storage, we are also thinking about the transmission time as well. So one thing is the storage, second thing is the transmission time, and then data volume will also go down. And then like next thing is we want to remove the redundancy in the data. Like if there is a multiple repetitions, we want to remove it from the data sets, basically to compress it. So in that sense, like now given this statement, which you can see is like A, B, 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 C, 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 like this. So if I give you the task, you have to compress this statement. How will you do that? So given task is you have to compress this statement which is given here. How will you do that?
By using coding,
Yes, like can you give me the answer? Like how, which kind of code?
it's a simple. It's can be go through the line coding because for all the A we can consider as just a single num code. For B there is
Yes,
another single code by that way.
yes, exactly. So what we can do is how many times A is there? 6 times A is there. So we can write 6A. Okay. Then how many times B is there? 4 times. So we can write 4B. And how many times C is there? So 9 times. So we can write 9C. So the compressed version of this is 6A, 4B, 9C. But how do we get to know that what kind of method we have used for encoding? So that methods are described in the lectures as well, that we have multiple methods such as uh, line encoding, block encoding, then Mr. Sid, then LSW kind of compression techniques. So various compression techniques are available depending on which software you are using and which methods it is utilizing. Based on that, in the metadata file or the information file, you will see the information about this compression or encoding method which is there in the file, so that it will easy for us to if we do the encoding, then it's easy for us to decode the image further or the text further. Now let's say the one concept which is a chain encoding. So in this concept what we do is we will uh, cover the boundary of the polygon which we are here. So basically these methods are for raster data. Okay, so here how we will do this thing, chain encoding. In this case, we have this. Let me turn on my pointer. Mm, Yeah. So here you can see we have this kind of layer. Let's say this might be represents a city or water body or anything. So how we will encode this into the framework is like, first we will start with the original point from which the corresponding part is starting. So let's say we'll consider the starting point over here, which is a 5 comma 2 represented by x and y coordinate. Then after we will use the directional encoding. So basically in the different direction we'll go and how many steps we have to go in that particular direction, that we will notify here. So here how will we do this thing encoding is like, say if we are starting from here, we have to go eastward in 3 steps, then move towards the south side and go 4 steps. So 1, 2, 3 and 4. Then after what we have is, so what we have to do now is we have to take a turn towards the west side. So one step one side, west side, then another during south side, then another west side one step. So like this you will do, then northward west, then west side one step, and then north side three step, 1, 2, 3, then east side one, and then north side one. So like this you will cover the entire boundary of the object, and then like given values are similar, so you can represent it using just one value. So this is a chain encoding. The next method is run length encoding. So in this what will happen is you have to specify the what kind of data it has along with its coordinates. So first of all, you will specify the dimension of the image. So here we have 8 rows, 8 column and 1 band. If you have multiple band, then you can write RGB or something like that as well. So here there is nothing in the line number 1. So we can say that in the like first line, like 0 to 8, it's a like all the 8 blocks are 0. So then we have the second line. So initial 4 blocks are 0. Then next 3 blocks are 1. And then next 1 block is 0. Similarly, for line number 3, we have initial 3 blocks as 0. Then next 4 blocks as 1, and then 1 block as a 0. So similarly, we will compress this data and it will become in this much format rather than representing each and every cell. So basically what we are doing, wherever the 0 or there is no data, we are making into 1, so that it will remove the redundancy, and we are specifying that is row wise operation. So it's a lengthwise we are going one by one. Then we have another type, which is a block encoding. So here what we will see, we will find a largest chunk of box, which is a square box in the image. So here you can see like the maximum box, which is square, is a 3 cross 3s. So basically covering the 9 pixel. And then we will specify how many counts, like how many such kind of blocks are there. And then after we will specify the coordinate from which that box is starting. So considering this box, it is starting from 5 comma 2. So basically 5 comma 2 and the size of that box is 9. So 3 cross 3. Similarly, now after 3 cross 3, we have 2 cross 2. So how many boxes are having 2 cross 2 size? So there are two number of box. And what are the coordinates for those two box? 4 comma 5 and then another is 6 comma 5. After that, we have block size 1. So we will go like biggest, largest to smallest. And if you see 1, 2, or basically one size will be 1, 4, 9, then we will have 16, then 25. So it will go like that. And then after, we'll specify the coordinates of each and every individual boxes. Then we have code tree encoding methods. So this method is like you consider your box into four different parts. Now if you see the first box, is there any further partition is there? No, then it will associated with just one value. Similarly, for this box, do it has any further classification or any other subpixel variability? No, then just one representation. Now we'll see towards this particular box. So if we go towards like this, now it will further divide it into another four grids. So now we will see three are green, so that will not have within the box variability. Whereas when we talk about this box, it has further variability. So what is that variability is? One green, one orange, and two red. Further, if it has more pixels within it, then we'll go further down also. So this representation is known as a quad tree encoding. So these four are basic encoding techniques which we use in GIS. Apart from that, there are multiple, around 10 like encoding methods which are given in the lectures, which you can go through if you have not gone through through the slides. So I will just give the name of few methods which are given in the classes. So we have Mr. Seeds and then LSW. So those methods are useful when you have the image dimensions are very large and how to get like which encoding to use. So mostly it will depend on the softwares what you are using and then how much compressions you want to do. So if you are doing for just a normal application part, like it will not create a problem much. But as you go towards the higher and higher data volumes, such as you are working with all India data sets or data sets of a state covering a last 40 years, then it will become a problem and then you have to think about those things. But if for normal case purpose or for normal project work, you might not need to go into detail about these methods. So these are the few things which is there. And then if you use E3 and all, so they have some couple of licensed raster data compression techniques also. LZ77, then we have Mr. Seeds, LZW compression, then the compression which we do using JPG formats and GIF formats as well. So those are the other way to do the compression. Any issue or question in this compression, raster data compression part, like any general issue do you have? Okay, so if there is no any questions on this raster data compression part, then so basically in the last week, two lectures were on this raster data compression techniques, and then after we have another class which was on georeferencing. Okay, so first of all, let me ask you a question so that we can make this class more interactive. So why there is a need for georeferencing, or you can say geometric corrections? So why do we need georeferencing? Can anyone tell me? You can unmute yourself and tell me.
Sir, if I can explain, actually when images are taken from satellite,
Yes.
since the Earth's surface is curve one or the what we call is spheroid, And when we superimpose that image to GIS, so basically we are superimposing in a 2D analysis platform.
Hmm.
So in order to to convert that thing into related to the image obtained from the satellite, we need a geographic.
Yeah, so that is one of the reason. And the most reason what I can say you is like when you take any image, how do you know from which area you have taken that image? Like if I give you any image, like consider the image of mine. So how will you get to know that from which location I do belong? Like you don't know.
Yes,
So
sir.
we have to add location information within the image. Okay. So that is a primary reason. First thing. Second thing, when we collect the data, as you told, that there might be curvature or significant effect of topography, or the area will be very large. Because of that, we need to consider the curvature of Earth. Apart from that, let's say flight is going like this and it got tilted in this way or this way, let's say, or the elevation got, let's say, wind came and it got a little bit up and little bit down. So all of it will change how we are capturing the image. Basically, it will change the pixel size, because let's say if I'm taking my image at constant elevation and if I'm going like this and suddenly I'm going little bit up, then what will happen? It will cover more area. If I will go down, then it will same pixel will cover less area. So this kind of things will happen. Apart from that, it may tilt also, it may go like this also. And one of the reason is key to add the location information. So basic idea is, what we want to do is, whatever the image which we have taken through satellite, that we want to pinpoint on the map. And as you told, like map is 2D representation of 3D Earth. So there will be issue because of projections as well. So we want to consider everything, and that is a process. The georeferencing is the process through which we are performing these operations. Now, if you recall in the lectures, we do this process into three different steps. So the first step is you have to identify GCPs. GCPs are a ground control points, basically. Like how you will get to know that image which I am providing, it's exactly going to pinpoint at given location. So I will identify some points in an image which are permanent in nature. Now, how do I check the features are permanent in nature? So for that, what I will consider is like, let's say if any temple, church, or any building is there which is not changed in the last few years, or if any government or buildings, PWD office, or any bridge, or any site, let's say a post office. So if any permanent size is there, location is there, I will find that and I will consider the points of those location as a permanent point. After that, I will try to see it should be distributed in my entire image, and then after I will select the function through which I want to do georeferencing. So that function is what kind of polynomial functions you want to use. And then after you have to apply the resampling method, which is might be bilinear or quadratic or cubic interpolation. So, and then using that you do the resampling and your image will be converted from one coordinate system to another, or you can say from real image or to real image, real earth image. Okay, so that is a process of georeferencing. Now I will show you some of the things which are covered in the lecture, so you will get more clarity on this. So how the parameter of your plane or the vehicle which is taking image will affect the image quality or the pixel quality. So here you can see your image is like the aircraft which is taking the data is going in this direction. Okay, now this is nominally, like in general you will get this kind of image. But now what will happen, that if the aeroplane or the craft or the platform, if it will go up, then it will cover larger area. The pixel size will become, like its a swath will become increased, or you can say the instantaneous field of view will change. Similarly, if you reduce the altitude, it will become like this. Now considering the roll, the angle, which is like this or this, so what will happen, it will be compressed on one side and it will expand on the another side. Okay, depending on which kind of roll is happening. So roll will happen along the x-axis. So when you think about this aircraft or drone data acquisition, you should think about this terminology as well, this roll, pitch and yaw. So roll is basically the rotation about the x-axis. Pitch is the like rotation about the y-axis. So like now if I will do like y-axis, it will be like this. X-axis will be like this. Okay. So here if I will do the rotation around the y-axis, then what kind of thing will happen? It will become upside down, and like the compression and expansion will happen, but it will happen on the direction of pitch side. So basically upside and downside, forward and backward. And now if any yaw is changing, which is a rotation around the z-axis, like this. Okay, so in that case, it will same thing will happen, expansion and contraction along the direction of z-axis. So this is how your image is going to be altered because of the change in the aircraft parameter. Now to fit this data, like these are the resampling methods you have learned. So I just kept the concept here, and we'll try to see this thing in the lecture also. We'll do a quick georeferencing using a sample image, so that you will get to know that what will be the effect of different resampling methods when we do the georeferencing. So basically this is the original observations which you are having. Now if we apply the linear function, then it will look like this. So linear will go like this. Okay. Now if I use the quadratic function, then it will go like this line which you are showing. So it will show the error. This will be like positive error. This will be negative error. And so you can see the errors are decreasing because my function is like this. Now if I will use cubic, then obviously what will happen, that error will further go down. But now it all depends on what kind of data you have. So basically which kind of resampling method should I use? The question is like that. So if your elevation is changing a lot, like if you are in a hilly terrain, then you might have to use cubic data because there will be curve like this. If you are in a flat terrain, you can go with a linear data sets if your surface is not changing much. If it is changing quadratically, so you change this. So basic idea is like you apply a function depending on knowing the geography of the region, and then after you also do the find the RMSC where you have actual point. So basically, if I tell you to find the RMSC here, so I already know the points, these points x and y coordinated, all the points which are denoted here. So I will take around 70% points to fit the curve, and 30% of points I will use to see what is the error in my data set, and through which I will find the best fitted function for resampling method. Now, I mean, why there is a need of this kind of resampling? So you are doing like this. So the image which you are capturing, it will be like this, little bit slanted, or it will be in this way. But now if you want to put it on 2D map, then you have to make it square. Okay, not the like this parallel or in the diagonal terms. So you have to make it like this. If it is just a transition, like see, either we have to do this, then we have to scale also, we have to shift also. So depending on what kind of operation we want to do, whether it's a translation, rotational, or scaling, we will do this affine transformation, which you have learned in the class. So here the coordinates of this 15 point, and if we want to put the same point over here, what will be the coordinate of this 15? Now to decide that, we can impose this grid and this grid, and then after, if it is nearest neighbor, then we'll consider the nearest point. If it is bilinear, then we'll consider the nearest 4 pixel. If it is cubic, then we'll use the nearest 16 pixels. So depending on that, we will do the resampling. Now, this is what do I mean by translation, scale, and shear or rotation. So basically, this is your original matrix. If you apply the translation, it will just shift your data. Okay, so here you can see the effect also. Okay, so original like matrix is x and y. Okay, just x comma y. So it's like this. So x, and here the function is y. Now, if you want to do the okay, now you want to do the translation. So basically you want to shift. So you have to add some additional parameter here. So I will add 1 over here. So this A naught and B naught will be useful for translation kind of thing. So if you want to do the translation from one location to another location. So if you add 1 1, it will be shifted by 1 1 location in both the direction. Now let's say you want to increase the scale. Then what function you will change here? So basically the coefficient of x and y only. If you will make it to 1 to 2, what will happen? It will increase the spacing between the points. So these two parameters which you are using here and here, that will represent your scaling parameter. Okay, that is representing your scaling parameters. So in that also in which direction you are specifying the scaling. Then after you want to do this kind of shears, so you have to edit this other parameter, this like basically this and this parameter. And here when you apply this formula, the like for second one, this coordinate with this e which you are specifying here, this will be b2, will be always kind of negative of y scale, because what will happen, like this image is going down like this, but if you consider real image, it will go, the coordinate system will start from like this. So basically because of those change in reference system in the image which we are having and the transformation system in which we are converting it, the reference systems are different, and that's why sometimes we add the negative sign here in the y of y predicted. Okay, so that was the basic concept, like just overview of the concept. Any doubt, anyone? Yeah, any doubt, anyone? Okay, so I think all of you have gone through these classes, so we will now start the session for MCQs, or basically our quiz part. Let me zoom my screen. I think I'm audible now. Okay, so this is the question answer session now. Let me hide this. Okay, so you guys have to respond, like you can unmute yourself and give the answers. I will repeat a question and options. If you need further clarification, you can ask that as well. What is the first question is, what is the primary theoretical justification for the effectiveness of raster compression in GIS? So why do we need a raster compression in GIS? The reduction of transmission time across network, spatial autocorrelation where nearby pixels are highly correlated, the ability to switch between thematic and continuous data formats, and the elimination of spectral and temporal redundancy in 8-bit image.
Is it D?
Yeah.
Yeah,
Option.
so here the answer will be very tricky, because see, the using raster compression, we are removing three type of redundancy: spectral, temporal, and spatial. Spatial means within the image what is the redundancy. Spectral means if you are having more number of bands, then how you are resolving. And temporal means like if you are having a image which is captured today and then another image is captured further. Okay, so for that we are having temporal redundancy. But if you see this question properly, they have asked about the primary and theoretical justification. So you have to always think about the one image format, like you just have one image. Okay, the option A is also true, option D is also true. Okay, the C is not true, but the more relevant one here is the option number B, because the main concept here is spatial autocorrelation, means the pixel which are here and then it is having spatial correlation with the nearby pixel, which are highly correlated with each other. So here, like you might think that we have multiple correct answer, but highly correlated is this. If you have, like, it's as it is asked, a primary theoretical justification. So that's why we'll go with the option number B. Otherwise, option A and D is also correct. Yeah. So the next question is, in chain encoding, how is the region's boundary mathematically represented? So as a sequence of unit vector in cardinal direction, as a successive division of 2 by n to 2 by n arrays, by recording only the end cell position within a row, by calculating the weighted average of 4 nearest boundary pixels.
Option A.
Sir, is it A?
Yes. So option A is the correct option. It's a sequence of unit vector in cardinal direction. So option A is correct. The next one is, which compression method is characterized as an extension of run length encoding into two-dimensional using square blocks? So quadtree, LZW, block, or Huffman. So this I think we just revisited.
Sir,
Quadtree.
quadtree?
Okay, not. So here in quadtree, also we are going from, like, it's not a extension of run length. It's using square blocks, but it's not an extension of run.
Block coding. Block coding.
Block coding. The correct answer is block coding. Okay. So in run length, what we will do, we will just take one line and we'll specify 0 and 1, then another line 0 and 1. Similarly, we'll do. So in block also we'll do like that. Instead of line, we will take and then we'll specify the, like, starting of that box and how many boxes are there. Okay. So the next question is, if a raster image is not perfectly square, how does a quadtree algorithm initiates the division process? So this is another limitations of quadtree also, like, which we cannot implement in the block, because for quadtree it should be always in square format. Then we can start with, like, first square and then the divided into 4 parts and then dividing into 4 parts. Okay, so the basic requirement for quadtree is having a square box. But if we do not have, then how can we do that? So for that, it utilizes 3n by 3n array instead of standard 2n array. It crops the image to the nearest small square power of 2. It extends the image to make it square before processing. And it applies a first order conformal transformation to the irregular boundaries.
Option C.
Is it option C?
Yes. So answer is correct. The answer is, it extends the image to nearest square, and then after we do the process. Okay. The next question is, which compression technique utilizes a table-based lookup algorithms and is basis for GIF and TIFF formats, which we are using nowadays? Huffman coding, LZW compression, JPEG, or you can say ISO 10918.
LZW.
Yes, so LZW is using a table-based lookup table, basically, to convert your image or to compress your image. So correct answer here is LZW compression method. The next one is, Huffman coding relies on which specific data characteristics to achieve lossless compression? The spatial resolution of the image, the frequency of occurrence of cell values, the presence of animated layers in GIF 89A, and RMSE values of the internal GCPs.
The frequency of occurrence of cell values?
Yes, so that is a correct answer. Frequency of occurrence of cell value. Based on that, it will do the compression, which is lossless. It means we are not losing the quality of image. So option B is the correct answer here. Let's move to the next question. Why is JPEG compression generally discouraged for analytical GIS thematic maps? It does not support the ISO 10918 standard. It is limited to only 29 district encoding process. It is lossy and results in a permanent decrease in image quality, and it cannot be used on extremely large images like Mr. Seed can.
It's lossy.
Option
Yes.
C.
Yes. So it's a lossy, and because of that, it reduces the image quality. The next question is, in the context of viewing performance, what is the primary function of pyramids? to provide a lossless backup of the original dataset, to create a reduced resolution representing for faster display, to correct geometric distortion due to Earth rotation, and to implement cubic convolution for sharper viewing.
Option B, sir.
Option B, to create a reduced resolution representation for a faster display. That is true answer. And like if you want to experience this thing, or you can open the Google map, you can just scroll it down to the entire world view and just directly go fastly to your Ahmedabad or your district level or village level part. So it will take some time to load. So basically behind the back, it is doing this pyramids only. So depends on how your pyramids are constructed and at which zoom level you are. It will depend on how much time it will take to represent that data layer. Okay, so the next question is, what is the standard downsampling scale for each successive layer in a raster pyramid? So corresponding to each zoom level, how much downscaling we are doing?
Option B, sir.
Yes, so we are doing a downscaling of 2 to the 2 raised to 1. So you guys have to go through the lectures if you want to answer, because otherwise it is very difficult to answer the questions. And you might expect this kind of questions in exams as well. So go through the lectures. It will be very easy afterward. So the next question is, which wavelet-based file format is specially designed for viewing and compressing extremely large images? GIF 87A, JPEG 2000, Mr. C, or LZW text compression?
Mr. C.
Mr. C.
Yes, the correct answer is Mr. Sit, option number C. Next question is, why is georeferencing necessary for scanned map or drone imagery? To eliminate spectral redundancy in the raw sensor, because location information is not integrated directly into the raw file, to convert image from 16-bit to 8-bit for LZW compatibility, to ensure the image is encoded in binary for GIF 89 standard.
Answer B.
Answer B, because to incorporate the location information. Next is, what is the primary goal of image to world transformation, which we do in GIS? To calculate the Huffman binary code for each symbol, to convert image coordinate to real world geographic coordinates, to reduce the transmission time of satellite packets, to find the frequency of occurrence of every pixel.
Option B, sir.
To convert the image coordinates to real world geographic coordinate system, option number B. So if you want to attend this quiz early, you can scan this QR code and you can see the questions as well. If you are a little bit behind, or if you want to go forward, you can use this QR code and it will show you all the questions in your screen, mobile phone or laptops. In georeferencing, which geometric distortion are considered systematic or non-systematic? Change in the color palette of a GIF, loss of quality due to JPEG 20:1 ratio, distortions from Earth rotations, altitude variation, and sensor pitch, difference between LZW and Hoffman lookup tables.
Option C, sir.
Yes, so that is coming because of the altitude variations. Straightforward, option number C. The next one is, what is the recommended spatial distribution for ground control points to achieve the best registration? Concentrating GCPs in center of image, using only the top left corner as origin, placing one GCP in each corner and a few in the interior, relying on animated features from GIF 89A for movement tracking.
Option C,
Option
sir.
C.
Yes, place one GCP in each corner for a few in the and a few in interior. Option number C is the correct one. Now the next one is, does adding an unlimited number of GCPs always yield a better georeferencing accuracy? Yes, accuracy increases linearly with every GCP added in the image. No, adding more GCPs does not yield better results at all time. No, GCP only work if they are taken from temporary features like clouds. Yes, but only if using Mr. Seed multi-resolution database.
Option B, sir.
Option number B, like whenever if we add n number of GCPs, it will not necessary that it will improve the accuracy. It depends on how you are distributing and whether it is actually increasing the performance or not. How many control points are mathematically required for second order transformation?
6, sir. 6.
6. Yes. Anyone else? So do you guys remember the formula to calculate number of? What is the formula to calculate number of points associated with any given polynomial and polynomial?
P plus 1 into P plus 2
So the formula
into
is P plus 1, P plus 2 divided by 2. If we put P equal to 2, it will become like 2 into 4, 8 divided, 12. Okay, like 2 plus 1 means 3, and then 2 plus 2, 4, 4 3s are 12, by 2, it will give you 6. And similarly, if we have 3-degree polynomial, then what will be the answer? Put 3 in the formula. P plus 1 into P plus 2 all divided by 2.
Ten.
Yes, so answer will be 10. So you will get 4 into 5 divided by 2. So 20 divided by 2, which will result into 10. Now, what is a thumb rule for this? Like if we like actual values are for 1-degree polynomial, we have 3 point, for 2 degree, 6 point, 3 degree, 10 point. But what is a rule of thumb which we are using in GIS while doing georeferencing? Like how much multiplier often should apply to get the minimum required GCPs? It should be multiplied by 2, 3, 10, or there is no need.
Option B, sir.
Yes, so the thumb rule is whatever answer you got, multiply it by 3. So for 1, if we are getting 3, so multiply it by 3. So you have to provide 9 reference point so that it will give a good results. Now the next one is in the 6-parameter affine transformation, which is defined by x1 is equal to ax plus by plus c. What do the terms c and f represent? So basically f means y1 is equal to dx plus fy plus e. So
Option
yes,
C.
option number
C.
C. So they are like translation terms, as we also seen in the PPT. The next question is, why is the y scale typically represented as negative value in georeferencing transformation? Because of the variation in the spacecraft velocity, due to the difference image origin is top left while geographic origin is bottom left. To account for the curvature of the earth in the third order warping, and it is requirement for LZW table based lookup algorithms.
Option B, sir.
Yes, so there is a problem in the origin which we are considering. The origin, or basically 0, 0 point in image is different and the geographic coordinate system is different. The next question is, what is the maximum acceptable root mean square error for standard georeferencing operations as per the provided text? Less than 1 meter, less than 5 meter, less than 10 meter, and less than half a pixel.
I think so it's half a pixel, less than half a pixel.
No, it's a like see the problem with pixel is how will you define pixel? Let's say if I have a 500-meter pixel resolution, then I cannot go for 250-meter error. Okay, in georeferencing. So basic task is like it should be less
For a
than 10
large scale
meter.
map, less than 1 meter is good, but for a
Yes,
small scale map, less than 10 meter is good.
yes.
It depends
So
on the space.
yeah, depend on scale as well, like how much detail also you need. So generally, when we take using satellite data sets, we'll consider 10 meter. If we are going for drones, we will have to consider less than 1 meter. Okay, so correct answer here considering it's for satellite image, less than 10 meter will be the correct option. Which resampling method is most effective regarding the computation time? Bilinear interpolation, cubic convolution, nearest neighbor, and Huffman binary resampling. So
Nearest neighbor.
nearest neighbor, true, because you just okay. Which resampling method is the most efficient? Now, what is given here? Resampling method. Okay, so yeah, I think we can go for bilinear or nearest neighbor. I think yeah, correct answer should be nearest neighbor rather than bilinear because it's like more. Correct answer here should be nearest neighbor. Okay, so that's my bad. It should be nearest neighbor because it will do because we don't have to consider like any kind of mathematical equations. Whatever is nearby, just put it as a pixel. So yeah, nearest neighbor will be the correct answer. The next one is, what is a major disadvantage of nearest neighbor resampling method? It alters the original pixel value significantly. The output image may appear jagged or blocky. It takes 10 times longer time than binary interpolation, and it requires at least 15 GCPs to function.
Option B.
Option number B. Okay, the output image may be quite jaggery or blocky because of they are just considering the nearest value only. So it will create a block-like patterns. So option number B. The next one is, how does bilinear interpolation determines the new values of a pixel? By picking the value of a single closest pixel, by taking a weighted average of 4 nearest pixel, by considering a 16 pixels neighborhood, by dividing the 2n array into quadrants.
Option B, sir.
Yes, so 4 nearest pixels. And now if we think same for cubic, then how many points do we take? So basically in this question, if I ask you like for cubic interpolation, then the answer would be
16 pixels.
16 pixels. Okay. So the next one is, which resampling methods produce the smoothest appearance because of blurry and loss of resolution? Nearest neighbor, bilinear, cubic convolution, or first order conformal transformation? So smoothness will come in which kind of resampling method?
Bilinear.
Yes, it will come, but if you compare bilinear and cubic will be more rather than bilinear, because bilinear we are just using a linear function. So as I showed you in the PPT which I presented. So if you see the how they are taking the representing the scale. So here you can see if we are going from linear to cubic, the errors are reducing. It is appearing like a curve. Okay, so that's why the answer should be cubic convolution. Option number C. So if our data is like that, then it may create loss also because we are doing blurring. And if data is like that rapidly changing, then in that case it may appear good as well. So how many pixels do we consider in cubic convolution? So you already told it's 16. So option number C. Yeah, the next question is, why is the cubic convolution generally not recommended for scientific analysis of pixel value? It is too fast to be accurate. It results in a jagged or blocky appearance. The new value differs significantly from the actual original values, and it cannot be used for grayscale images.
Option C.
Yes, so because it does like lot of smoothing, we are having loss and it's differently varying from the original values. Option number C is correct. The next one is which georeferencing transformation order is specifically used for warping an image? So first order, second order, third order, or least square feet.
Option C, sir.
Option number C.
C.
Okay, third order. So that is, I think, a true answer. So if we see that if we are using first order or conformal, they are used for transformation type of corrections. Then if we consider the second order or affine transformation, then it will be useful for transformation, rotation, and change in scale. And then third order will be transformation, rotation, scales, and warping as well. So can anyone tell me about what is warping? Can anyone tell me about what do you mean by warping? Any idea?
Shows
Significant
curve.
distortion of the image
Uh,
to fit the coordinate.
yes. So basically distortion. So it's kind of more of non-systematic, or we can say the translation, rotation, and scaling is kind of square only. But here the warping will make like it will curved features. And why that will happen? Like someone told that when you do this thing, it will be like either because of the curved nature of the earth, or we had some curvature corrections, or it got literally like while collecting it got warped, okay, the image. And sometimes when we do the transformation from one coordinate system to another, in which we are showing the like curvature of the earth, during that time also this warping will affect. Okay.
The sensor angle will also lead to warping.
Yes, exactly. So angular effect also will lead to warping. Yeah, true. Okay, so for that. Yeah, so next we have what type of redundancy refer to the correlation between different bands in a satellite image? So spatial redundancy, spectral, temporal, or geometric?
Spectrum.
Spectral. It depends. Bands means spectral. Time means temporal. And within the image means spatial. Which GIF version supports animated images? GIF 87A, GIF 89A, GIF ISO 10918, or GIF LZW Wave80?
G59A.
89. It's a 89A. So option number B is correct option. Okay. So here we have having the end of first session, which is our quiz. So I hope you enjoyed the quiz. If this question looks difficult to you, I request everyone to go through the lecture again. Okay. And I have not included the content of, I think, here in this particular quiz. I have not included the questions from the last video, which was on the demonstration part and one of the pre-processing of spatial data sets. So what I thought of the two topic, which is pre-processing of spatial data sets and interpolation related MCQs, we will discuss in the next lecture only. Okay. So that is the plan for the next lecture. Now we'll move toward the second portion of this class, where I will help you to explore the various data sets. Before that, anyone has any questions?
I have a one. Hello. Uh, how,
Can you just
how
introduce
can I
yourself?
measure?
Yeah.
Hello.
Yeah. Go
How
ahead.
can how can I measure the surface area and planimetric area from a depth in QGIS?
Okay, in QGIS. Okay, yeah, nice. So let me open QGIS. Okay. So let me open some data sets as well. Um, mm, Let me open some data if I have. Mm, Okay, let's say I have this kind of data. Okay, so here there is a measure line. Can you see that?
Yes.
Okay, so if you click over here in the triangle part, then there is option of measure area. Okay, now it will ask you the two things, Cartesian and ellipsoidal. Okay, so this is not with respect to planimetric and those things. Like Cartesian coordinate system is 0, 0, and ellipsoidal, it means like like kind of which datum you are using. So ellipsoid is also a mathematical datum. So you can see here, you can see the effect. So which area you are using. So ellipsoidal area is a mathematical surface. So which is a ellipsoid surface only. Whereas Cartesian is actual coordinate system which we are using. So that will be high and ellipsoid will be less. Apart from that, whenever you have, this is the raster, so it will be difficult. But if you have any vector data set, let's say, let me open some shape file. Okay, now here, if you go to attribute table, okay, take any file, vector file, and go to attribute table. Now you can go open field calculator. Okay, so basically here you can add different properties into your attributes. Basically, if I want to add area feature, then I will create a column of area. Area will be always in float, so I will consider the decimal numbers, and here I will select the option to area. So okay, here the option of area is there. Now you should question which kind of area it will give me. So it returns the area of a current feature. The area calculated by this function respects both the current project's ellipsoid setting and the area unit setting. It means that it will be determined based on what kind of coordinate system you are using. Okay, so if your coordinates, okay, basically if you use dollar area, then always it will give you the units in meter. But otherwise, if you use this area, then it will consider the planimetric in spatial reference. Basically, calculations are always planimetric in spatial reference systems of this geometry. So if you select these options, then it will be always planimetric. Always. This differs from the calculation performed by this dollar area function, which will perform the ellipsoidal calculation based on project's ellipsoid and area unit setting. So that settings you can change based on the coordinate system which you have. So if your coordinate system is in degree, then it will give you the area which is in degree, which will be by your actual area. But if your project units are in meter, then it will give you the planimetric area. How will you check? So for that, you have to right click and go to the information, and you can check which coordinate system your file is. So currently my file is in having units are in meter. It is a projected coordinate system. It means it's in a two-dimensional. So it will give me the planimetric area. Getting my point?
Yes, but when I am using this UTM or projected coordinate system, I am getting the planimetric area. But the real area, ground area, is different from the planimetric area,
Yes. So for
which has
that, what you have to do
around.
is you have to convert your data into geographic coordinate system
Okay.
from UTM to geographic coordinate system. Then
And
it will
then
become in degree, and then
without
change
then
the
I calculate that without that dollar sign, that area, right?
yes.
Okay, okay, okay.
Okay,
Thank you.
so it will consider what kind of coordinate system you have. If you will use just without dollar sign, then it will always give the same area in normal coordinate system, planimetric area, without considering the projection system. And if you will use the dollar sign like with the value, it will consider the coordinate system in which your data and units are. Okay.
Yes, I understand. Thank you.
Okay. Any other questions? You can check this thing also, like what I will show you one more thing. So if you go to Google Earth Pro, I mean, I don't know how will it be helpful to you, but I think let me show here as well. So in Google Earth Pro also we have feature for this area calculation, which will be give you the both the areas basically. So this is not a Google Maps, this is Google Earth Pro, okay? So I think we should go to some locations where we have mountains or other things, so we'll get more idea. Okay. So here, there is a ruler option. Then there is a option
Your
to.
screen is not changing. It's still in QGIS.
Okay, in my it is showing changing. Is anyone else is having same issues? I think you should check your internet connections because in my I have opened in two systems, so there it is showing change. Can anyone just tell me, like all of you are having this
Oh,
issue?
it is changing. You
It's
are
changing, yeah?
zooming in a mountainous area.
Yes, yes. Okay. So I think you can check your internet connection, those. Okay. So what I will do is I will create a polygon and I will create a polygon here. Okay. Now if you go to measurements and then in area, you will having this units basically. And here also, see, these are the like various altitude with reference to what I think it has one option. I'm not able to find it right now. Okay, yeah. So here, this ruler option, if you will go, then it will show you the line path. So it will show you the map length and ground length. So what length you have actually on map and what on ground. Okay. And ground is what that also you have to specify basically. So that will depend on the your elevation and the layer which you are using. So here both are showing change, and sometimes like there is a like it will happen when you have a longer distance, then it will show major change. So you can see if I am taking more distance, then it will show you change in map length and ground length. But in the shorter length, it will not change much. So this is map and ground length, but this is still not exact. Okay. Similar thing is with your polygon. So here, if I will create an area feature, I think in area it is directly given area, not the. So measurement of the distance of area of a geometric shape on the ground, it is giving directly. Okay. Yeah, so it is not having, so 3D path and 3D polygon, I think that will give you the 3D area. So this polygon will give you the planimetric area and 3D polygon will give you the 3D areas. So I think you can just check these options and how it is changing, like you just do, and we can discuss that in the next class as well. Okay. Okay, so today what I thought of that we will download a image basically, and we will try to do georeferencing of it. So let me just ask every one of you that have you performed any georeferencing operation before? So can I have anyone used
No, sir.
georeferencing operation before?
Yes.
Yes,
Yes.
sir.
Okay. Okay. So yeah. So can you tell me like from what was the source of the input image which you have used? So on which image you have done the georeferencing? That image from where you have collected?
Actually, I have collected some topo sheets from Nakshe, and then I do the georeferencing. Also, I use some satellite image as well.
Yes. Yes. Exactly. So that is one point of images which are not georeferenced. So basically my idea is I want to get to know like what kind of data are not georeferenced. Okay. So one thing is the like Survey of India topo sheets or the topo sheet from US Army or basically any maps which are generated long back, and then you want to digitize the same old maps. Okay. So then there is a concept of georeferencing will apply on that. Another thing is like anything else. So one thing is topo sheets. What else?
I have performed georeferencing on satellite images. Those
Satellite
earlier
images.
days, those were not georeferenced.
Okay. So can you give me the example from where you have downloaded those? Because now, see, if
we
you
we,
down.
we used to order them from uh,
Okay, nice.
uh,
Okay, so yeah, this is a very another important issue. Like if you will order from some other agency, it might not be a geo-referenced image. Otherwise, if you are using currently available satellite data such as Landsat, Sentinel, Moody's, so what is happening is like all those images are mostly geo-referenced nowadays. Like they are atmospherically correction is done, geo-referencing correction is done, radiometric corrections are done. But yeah, if you are taking raw images from some sources, then yeah, there is a need to do georeferencing. Anything else?
So we also run georeferencing in cadastral maps, revenue maps.
Yes, exactly. So that is another point. Like government officers or someone who is planning, they give you a map, and now you want to see that you have given the project, okay, and now you can see that lots of things are happening. That roads are going here and there, they are constructing. So basically, if we are implementing any projects we have done on AutoCAD or some software, we have done the design in computers. Now we want to see where that project is going to laid off. So what we'll do, we'll take those maps, which is prepared by the civil engineers or the planners. We will georeference that map and we will integrate with the existing available database of the city. So that we will get to know, first of all, that how many land parcels are going to be affected because of that new construction of road or let's say over foot over bridge or any kind of platforms, okay, or metro stations. Okay, so that is another thing. Okay, anything else? Cadastral maps, topo sheets, and satellite images from private sources.
urban word map.
Yes. Okay. Then some of the other applications are like someone did a research, they published a map, and you want to use the same thing, but you do not have the data, or that person is not responding, or that data is not available. So best way to georeference those data. Another thing is like uh, you want to see that how much urbanization happened in Bangalore, or let's say we will take a classic example of city of Dholavira. Okay, we have a long map of Dholavira from let's 100 to 100 year back, let's say, and then we want to see how much area is developed across that town of Dholavira. So what we will do, we'll take that old map, we'll scan it, and then we'll make a digital copy of it, and then we'll put that into QGIS system. And in this way, we will get some image, and based on that, we will do a georeferencing. Okay. Now, if you are a student and if you want to use topo sheets, you can use Survey of India's portal. These topo sheets are freely available for all the India, and you have to create an account, fill a form. You have to submit your details with your institutional details, and you can download the few numbers of image in a like topo sheets in a day. Apart from that, what we are going to do is I will show you some data sets of wetlands. So, does anyone know about anything about wetlands? So the source is covered, like from where we will get the images and for which the georeferencing is necessary. Okay, so this is the some kind of application towards the biodiversity and environmental side. Okay, so this wetlands are the site which are like having ecological importance, and it's good for human survival as well. Like if it is an environmental setting which will suppress the carbon dioxide, it will like help us to protect the floods, and it will support the lots of species of plants and animals. Now this Ramsar sites across the world, they have specific things that if it is following this criteria, then and then it will be considered as a Ramsar sites. Now, why we are discussing it is like we'll see that how the sites are represented across the world using the GIS data. So if you see the like if I just click on the Ramsar site list, so let's see we will have map or not. So let's see. So okay, we'll want to see all the Ramsar sites. These are the different Ramsar sites in the different uh, like different countries. And let's see, I want to check a mapper version of it. So basically there are multiple sites like this where the data is provided and you can take that data and you can convert that data into a GIS ready data sets. Um, let me check. So they have one portal. Okay, so here you can see like they're showing a map and then various Ramsar sites and where they are located. It is shown here. Okay, and then you have criteria like 1, 2, 3 criteria. How many of them are meeting those criteria basically? Okay, so the first criteria is what, second criteria is what. So those things you can see here. Now, like if first of all, this is which kind of data? If we talk about the GIS data,
Raster data, sir.
raster or vector?
It's a point data.
Pointer
Yes,
vector.
it is a point data, which is a vector data format. Now, if I go in detail, now can you see me? There are any other layers are available. So you can see the polygons, which are
Hmm.
blue. Okay, so that will represent the spatial extent of that wetland site. Now, if I do zoom further, okay, so you can see those sites very clearly. So what I will do is I will take one site in Gujarat. So basically, this is one of the bird sanctuary. Okay, so this sites I want to take. Now I will search about that particular site. Uh, basically, let's say, or let me search only site name. So basically here you have seen that download RSI. Matlab, for the given file, you can download the data sets for that GIS ready data sets. Let me open in my whole wetland Ramsar site. Okay, so like that site is laking, so I will just, if you will click on that whole lake wildlife sanctuary part, which we have seen like this, you will see this page will come, Thol Lake Wildlife Sanctuary. Now it will show you the coordinates at which it is located. This will be might be the central coordinate of the polygon which you are seeing, where it is designated as a site number, area, where it is. Now if you see in the download pages, you are having, like when we apply for this kind of conventions, whether it's a Ramsar site convention or UNESCO site, we have to prepare a map that how much area it is covering and in how much area the, like if it is UNESCO site, how much area the construction should not be done in the further, or any archaeological site surveyed by like given by the Archaeological Survey of India. We have to specify the boundary of the site and the buffer regions of the site as well. That in this much part there should be no any construction should happen to preserve the values of for the that particular site or ecology associated with that site. So if we click here site map, then you can see two JPEG image are there. Now, if you will open, it will open this kind of image, which is a kind of a map. Okay, and our task is, this is a JPEG image. So generally, we'll just download it, and our task is we want to digitize the boundary of this site. So what we will do, we will save this image. So basically, go toward the temp file. Okay, so I have downloaded that image. Okay, and now what I will do, I will upload the same image in my QGIS. Okay, everything is fine till now at this point of time.
Yes.
Okay, So you can open any such kind of image. So this is the image in which it is already available. And the good thing here is, like, we know, like, see, the first thing is when I uploaded this image in QGIS, I want to know from which area it is. Okay, from myself, it is know that it is from Gujarat. But if I will add a base map, let's say Google Map, if I will add here, it will not show me anything because see, Google Map is coming over here and my image is coming over here. So first of all, why this is happening? And this thing will happen actually with you when you start working with the GIS datasets. So you should be ready with the reasoning.
Coordinates.
Yeah, the issue is coordinates. Now, what is the issue? So
This map is not georeference.
exactly, the map is not georeferenced map. It looks like the coordinates are given, but image is JPEG format. It is not georeferenced format. Okay. So for that, what we have to do is we have to perform the georeferencing operation. And we also have to see, like, see, in general, if we see the lat long values, it will go towards how much it will go if India is there, let's say world is there. Okay. So from this, like, it will go from minus 180 to 180. And from here, it will go from 0 to 90 and 0 to minus 90. But if you see over here, it will go beyond that as well. Okay. And very weird number you will see. So that should not happen actually, because this is not a georeferenced image. This is happening. Okay. So to avoid that, what I will do is I will remove this image, or let's say we'll keep it here. Now, I will open my georeferencing window. So for that, what you have to do is you can go to layer and georeferencer. If you are using the previous version of QGIS, then you can see the same option under the raster tab. Otherwise, you will see the same option under layer and georeferencer. So I will click on georeferencer. It will open me the window of georeferencing. Now I will click on open raster. So I will open the same image which I have uploaded over here. So let me go to my folder and open the file. Now I have opened the file. Now, first of all, let's say I will show you the different options. So these options are the open vector. So if you have any vector data set also, that also you can georeference. Do you think that vector data might be available without georeferencing? Do you think so that vector data generally we create over a map or something? But do you think so that this might also happen, that we have to digitize, like georeference the vector data as well sometimes?
When we need specific transformation, then we have to reproject or re-georeference sometimes. Then usually then we do this type of vector georeference.
Okay, but the problem is this will mostly happen when we are creating a data by self. Like I am a worker who is creating a multiple GIS files, digitizing, and sometimes I forgot to associate the coordinate system. I have associated the, like I want to have to create my data in a, let's say, degree, but I've created in meter or inch or any random unit. Then what will happen, that you are seeing the vector data properly, but it is not overlapping on a world image. Okay, so to avoid those kind of things, or what you have done is you have taken this image and you don't know that this image is not georeferenced, and you started tracing and you already saved the file also. When you will open this file again with some data, and then you will see, yeah, this GIS data is not overlapping with my data. So this is the issue while creation. One who is responsible for creating vector data, that person has done some mistakes, and because of that there is a issue in a, that layer is not properly georeferenced. Now this is the to start the georeferencing. So this button we will use. Then this is the, like if you want to generate a script of the workflow. Then these are the load GCP points. So you already know that this XY data we want to transfer into this data. So if you know those things early only, then you can load and GCP data. These are the transformational settings we want to do. Like as we have seen that linear, cubic, or bilinear, what kind of transformation we want to do. Then this one is to add a GCP point. Now GCP point is like ground control points, and mostly we will specify in each corners. Okay, so we'll start adding a GCP points. So where will we get to know that which point to use as a GCP points? So first of all, in this map, you can see we have given the latitude and longitude. So we know the x coordinate of this location is 72 degree 23 minutes. And if we see the y coordinate, then at this location it is 23 degree 10. But you can see there is a fine line which is passing in the image, which is also known as a grid line. Okay, now if you combine these two grid lines and if you see this corner, so what you can do is you can do the at max zooming, which is possible. Now you can go exactly into the center of these two lines and you create a point. You click on that. So it will ask you to add the XY data for that location. So now I will do this again and I will check the location. Okay, now what is the easting? So easting is 72 23 00 and northing is 23 10. So here it is written that how you have to enter the data point also. So if you are providing your data into degree, minute, second, then you have to provide degree, then spacing, then minute, then spacing, and then seconds. If you are providing your data in decimal degree, then 72.2544 or something like that you have to write. And if you are providing your data into meter, so someone was talking about their georeferencing cadastral maps. So in that case, your data might be in meters or any property related maps. So that case, you have to use the coordinate systems in projected. Okay, so you have to keep in mind how you are adding the data of X and Y. Now, this data coordinate systems are in degree. So you will select the coordinate system which is in degree. So this 4326 and EPSG 4326 WGS 84 is a coordinate system which is in which the data is in degree. So I will use that. Okay, and then I will click on OK. So what it is giving me that source X and source Y means in original image, the X and Y coordinate of this location is 529 and minus 794. But when I want to transform that image into the new image or in the actual coordinate or the georeferenced coordinate system, it X should become 72.383333 and Y should become 23.166667. Okay, so like this it will do the transformation and it will use the formula that we will discuss in just a few minutes. Now the thumb rule is collect the data point from every corners and then go into the side. So right now what we'll do, we'll collect the data point from all the corners, considering that we want to do a linear projection. Minimum requirement is 3. So we'll collect 4 points for 4 corners to save the time basically. So you can see now here the lines are breaking. So you have to select, because of that you will get an error. Okay, but let's see how much error we will get. So coordinates for this point is 72, 26, 30 and 23, 10. Now for this point, similarly we will do so 72, 26, 30 and 23, 7, 30. And then we'll go here and do for the last point. So 72, 23 and 23, 7, 30. Okay, so now you know that I have added the 4 coordinates. Okay, and what you can see here, if you will go and zoom into that particular pixel level, you can see The location is over here, but what it is showing a red line. It means it is showing me you transfer your data from this location to this location to maintain the accuracy. And why that is coming, you can see these lines are breaking. So basically when you scan your maps or take a photo of your map, it is not at a very high resolution. So this pixelation will happen. And because of that, you will lose the accuracy in your image while doing georeferencing. Now we can add more image so that it will get better. But what we can do is we can just try to move the point also here and there. So if you want to move it here or something, let's say considering, so you can see the error will go down. So little bit you have to do, you can increase the number of point also, you can specify it more properly as well, but depends on what kind of input you have. So if your input is garbage, then you will not expect that more accuracy in your georeferencing operation. So here you can see we are having the pixel like errors of in X direction, error in Y direction, and residual pixel. So it's a resultant error. So it's a 12 pixel error we are having right now. Now you have to see like how much 1 pixel is contributing. So you can check that, and then after you can see whether it's within the permissible limit or not. Okay, so you can adjust this thing by adding more point or by changing the line. And then after you have to select the transformation settings. So here transformation type. So we want to do a linear transformation, but there are option of polynomial 1, 2, 3, and there are some other transformation also, which we have not learned in the class, which is Helmut, thin plate spline, or projective. So currently we are going with linear transformation only. And the coordinate system in which we are transforming the data, it is 4326 only. If you want to use polynomial 2 or polynomial 3, then you have to add more number of points. Otherwise, it will give you an error. Now, this is the location where you want to save your file. So I want to save my file here only with this name. Now, the third step is, first step is selection of GCP. Then second step is selection of transformation type. And third step was resampling. So which resampling you want to do? Nearest neighbor, bilinear. So bilinear using 2 by 2 kernel. Means it will use the 2 cross 2 array, 4 pixels. Cubic using 4 cross 4, it means 16 pixels. Cubic B-spline. So this is another method in which also it will use 16 nearby pixels. And then there is a LAN close system resampling, which will use 6 by 6 kernels. So currently, let's say we'll do with the nearest, the nearest neighbor. Now, whether you want to apply a compression to your image or not. So for that, this is the compression methods which are available in the QGIS. LZW, petabytes, or deflag. If you will not use any compression, the image size will be high. Okay. Now, using after this, if you want to save the reports of this georeferencing, basically, then you can click on reports also. I will save a PDF file of the report so that we can discuss that what it will show in the report as well. So I will have MSC. And then I will click on load in project when done. So once it is done, it will load in my QGIS window. So I will click on OK. Now, any doubt what we have done? We have selected the GCP points, transformation settings, then we have resampling method. And if we want to apply any compression, then we can apply the compression as well. Now, once you are done with that, you can click on start georeferencing. So once you click on start georeferencing, it will do the georeferencing, and then the layer was successfully georeferenced. And after that, if you open the original window, then you can see one more image is being added in this window with the name modified. And now if I will right click and go to zoom to layer, now you can see this is exactly on the map at the same area. So I will just do quickly turn on, turn off. Okay. And if I want to see it properly, then what I can do is I can just reduced its transparency to, let's say, 60%. So now you can see I am able to superimpose, and how you can check is you can check with the roads which are present in the image, the junctions of the road. Okay, so that thing will help you to validate whether you have done the proper georeferencing or not. So here you can see there is a 4 roads are crossing at these locations. So these things are clearly visible in image as well and here as well. And this is the something new road which is coming. So if you see the image which is being provided to you, so for that I think what we'll do, we will just open the Google satellite image so you will get more idea. Okay, so this is the Google satellite image of this same location, and you can see now this road is being constructed. But if you see the original image which we have, so in that you can see the construction of road is still going on, and how much, see, you can see the little bit here and there it is happening. It means same this much error we are having. Okay, so basically one old image you had, and then you georeferencing, do the georeferencing, and then you compare it with the recent georeferenced data. This will happen most of the time in archaeology, where you go to the field, library, or some ancient sources. You will collect the data, scan the maps, and do the georeferencing. And then after, you apply the same thing. Same thing goes with the cadastral maps. Now, to avoid this kind of things, what are the things which are actually happening in the field nowadays is like, if you are doing a project and then you want to get the environmental license for that project. So what you have to do is you have to also submit the KML file of the project from where to where it is starting. If you want to create a pipeline network which is passing through a forest area, then you have to create a exact georeferenced KML file or shape file in your, like, mostly KML file, which is easily uploaded in Google Earth Pro. So create a KML file, and then when you submit the data, you submit that KML file also with the project boundary. And then after, if forest department will take that file and they will import in the GIS software where they have their forest boundaries. And then they will tell you how much area of that forest or like pipeline is coming under the forest area. And based on that, how much compensation or how much actions should be taken, whether if it is less than some areas, should we approve it or not. And if you want to download this kind of things, then there is a site name as Parivesh. So if you see the parivesh.nic.in, so these are the site in which all the construction projects, whether it's industrial, residential, or the development projects in the India, basically whatever are going, they are we have to upload it on this portal for the approvals. So from this you can download the multiple KML file also, like if any project is going on, so you can just download the KML file also for the given process. So I mean, you can go and check in detail. So basically this is from Ministry of Environment, Forest and Climate Change. So basically save the file as a KML, draw boundary, zoom AOI. So this GIS steps are already coupled with the systems which we are using, whether it's a construction project of any kind of residential, industrial. So it's not like that we are not getting upgraded. So now whenever you do anything, it's you have to submit a GIS ready file so that people can do the quick estimation and rather than doing it. So basically these are the various things. So you can check, there are having particular portals also. I will share that link in the repository where I'm putting all the links. So you can go through this data sets again. So this is the two sites which we discussed today. This is the Parivesh site, and then another site is the Ramsar Convention site, and then used for georeferencing. Now, any doubt in the process of georeferencing? Anyone? Any doubt in the georeferencing, resampling part, transformations? Okay, so if no doubt, I think all of you will be able to do georeferencing very well now if you want to do for your work. Next thing, I think we have roughly around 10-15 minutes. So what we will do is, I will tell you like if you want to do digitization, how you can do it. Like in the previous two lectures, we have learned about the creation of, yeah. Okay. So in the previous two lectures, what we have learned about is how to visualize the data, whether it's a vector data or raster data. Now, if you want to create your own vector data, so basically what I'm telling is, we have georeferenced this file, and my task is to create a boundary along this pink line, which is being visible here. Then how to create a shapefile by myself or vector data by myself. So for that, data creation we will learn. So for that, you have to go to layer. Then after, you have to click on create layer, and here you can click on new shapefile layer. Now here you can click on this three dot and you can save the file name where you want to save your data. So I will write it as a polygon 1, and then geometry type. So I want to create a polygon. So I will select a polygon. Now the data which I have is in degree, minute, second coordinate system, which is 4326, which we have also selected while doing the georeferencing. So I will select same coordinate system. Then after, if I want to add any attributes, nominal, area, or any kind of attributes you want to add, then you can add those kind of attributes. So I will add a attribute, let's say site name. Okay, and it will be in text. I will click on add to field list, and then I will click on OK. Now to edit something into this layer, I have to go and click on this pencil button, which is a toggle editing. I have selected that. Now after that, it will highlight these options: add polygon features and vertex tool. Okay, so add polygon, like if you have created a point file, it will look like a point. If you are creating a line data, it will look like a line. If you are creating polygon, it will look like a polygon. So I will click on polygon, and then after, what I will do, I will zoom as much as possible, and then after I will start creating a polygon layer. So I have to maintain the proper accuracy to get the smooth nature of the file, and it will all depend on the input file which you have. If you have error or the coarser input file, you cannot expect more high resolution data. Your boundaries will be rough only in that case. So I think this is the way to do a georeferencing and then after digitization. Now, I mean, like this is the manual process only. You have to do it if you want to digitize a feature, and there will be a lot of job just because of this only. Now what you can do if you want to do some startup or something, and what other companies are doing is that they have digitized various data sets. That's a various commodity in the different urban cities, where the data of pipeline or data of various resources which are available within the city. And then what they are doing is they are selling the data to the different providers which needs the data. Someone is doing research, or someone is interested in the urban planning, or someone is doing the real estate work. So they are selling this data. So the thing is, right now in this age, like when we are having chat GPT or Gemini or any other AI tools, the main cost is we have to pay for the data. Everything can be built if we have the data. If we do not have data, we cannot do anything. Any training cannot be possible. So the main part is the data creation. And the companies who are involved in the data creation part, they are earning a lot. Okay, so whether it's a Geo, Airtel. So basically the thing is how you will create your geospatial data, and then after how you will sell it to the different authorities that will make all the, like that will change the game. So these are the, and then considering that we also have the geospatial data policies also in the India, which came recently. So, I mean, I will not do it properly. So I will just do it quickly. So now you got my point. Once you are done, you right click give the site name like ID, and I will specify here whole lake and click on OK, and it will create a polygon. Now someone will ask me, if I want to edit this polygon, how should I do that? So for editing part, you can click on this vertex tool. Now it will show me the different vertex. If I want to create a new vertex, I have to click in the middle of the line. So I will put this vertex over here. Similarly, I will again create another vertex like this. Okay, so similarly, if you forgot something to do, you can do the editing like this. You can explore. But yeah, if you missed something very marginally, and then you have to start again. So while doing this GIS, you should build patience in you. And I mean, if you will start doing it, it will build like lots of patience within you. Okay, so yeah, I mean, I'm not frustrated doing it. So I mean, this is when you start your projects, you should keep in mind of this kind of stuff. Okay, any questions? So this is like how we do the digitization. So this is a digitization of polygon. Similarly, you can do digitization, like once it is done editing, you can close the editing, you can click on this pencil button and you can save it. Now, if you go to right click, an attribute table, it will show the attributes. As I discussed earlier, you can add the area, perimeter, and the other terms also using field calculator. So if I will click on, if I want to add area, I will click area, decimal, and then I will search for the area feature, and I will click on OK. So this will be give me the area in meter square. So it will be around 7 square kilometer area. Okay, dividing by 10 to the power 6. So by default, if you do not provide anything, if you use $area function, it will give you area in square meter. Okay, and then if we can go to like this is not exit area, but yeah, if we can go to that site and this Ramsar site, and we can just verify it with it if the area is given. So yeah, area is around 699 hectare because which is equivalent to around 7 square kilometer. 1 square kilometer is 100 hectares, so around that only. So you can see that we are very accurate. And in which unit it is gives. So you should know that thing as well. Yeah. Okay, so that's that. Any questions, everyone? So this is like how you can create a different data sets, whether it's a line, point, polygon. Okay, so that was the GIS part. One of you have requested me, like they are working in the LULC. So we discussed that in the last class as well. So we'll try to cover that, like how to prepare a map. So in the next lab, we will also see like now you want to create a map such as the one which is shown here. So if you want to create a map, what kind of things you will keep in mind, how to create those kind of map in QGIS, because like that is very difficult part and some of the people do not do it properly and they come up with a very bad quality map. Like they have done the analysis very well, but the mapping part, like final publication ready images and maps are not visible, and because of that they find lots of difficulty here. So I think those minute details we will cover because that requires a lot of time. So we will consider that in the next class along with the interpolation and the other stuff, pre-processing part. Yeah, so that is everything for today's session. Any doubt? Anyone? So if not, then the floor is open. Like we have 5 more minutes, 5-10 minutes. If you want to discuss anything, you are welcome to do so. If you want to give any suggestions, improvement, which we can incorporate in this problem solving session classes, you are welcome to do so as well. Further, if you're doing any project work or something, we can discuss that as well. If it is permits within the space of this course, then we'll try to cover that as well, definitely. Anyone, any question, issue, any suggestion, discussion that you want to do? Yeah, if not, then like others can leave. Those who want to discussion, they can still be here. I will be available for 5 more minutes. Yeah, you can unmute yourself and you can ask. So if you have any questions, okay, do we get this live class recording? Yeah, so the recording of these classes are available on YouTube and in your okay, so how to okay, so first of all, let me cover this live recordings will be available on YouTube. You can search my YouTube channel Hiren Solanki and you can just do a subscribe. I will upload everything there. Apart from that, I will also uploading the links in the NPTEL portal as well. So if you go to NPTEL site and then problem solving session, you will get all the YouTube links as well as all the data links. Everything will be uploaded there. So I will show you which kind of let me share my screen. So yeah, you have this kind of Google Sheet link where I will be specifying the YouTube link of this sessions. Then the Google Forms for quiz, which I am sorry, Microsoft Forms for the quiz, which I am having. And then I have also uploaded the sample data, vector data, raster data for Delhi region. So you can also use that as well, which has archaeological site data, um, metro station, metro line data, and then a couple of other data sets as well. So if you want to practice by yourself, you can use those data as well. And these are the some of the links which we are using. So that is the thing through which you can explore the session. Now, if you want to start learning a QGIS, uh, I will try my best to cover you the basics in this class. So in this 12-week session, like we will devote 40 to 45 minutes on the basic part of QGIS. So you will get a lot of idea from this class. Apart from that, there are various YouTube channels which you can go through and learn. Uh, I will also upload some of it afterward. This course is over. So as we are doing this course, I will try my best. You will, if you will attend all the sessions, you will become around, and then you have to repeat the exercise also which we are doing. If you do so, then you will become around moderate level user of QGIS, and then you can do this various things by yourself. So the data sets I have given to you, you can take the data and do the same thing which we are doing here. So in the first 2 labs, we have learned about the how to visualize vector data, how to change symbology. In second labs, we have learned about the raster data, how to change the colors of the raster data, hill shade, from where to download the raster data. In this lab, we have learned about the georeferencing and data creation. The next lecture, we will try to learn interpolation and the map preparation. And then there will be subsequent classes where you will do the entire application part. If you want to solve this problem statement, how will you do using the GIS? Okay, so that thing I think we will do. I will also copy pasting this link of Excel sheet into your file. So the only one request, you guys just join these sessions so that you don't need to go through any lectures. And if you have any questions, you just raise it here. We'll try to solve it as early as possible. If not within the lecture, we can discuss that in the next lecture. Okay, any other questions, anyone? Or do you want to discuss anything? You can just type your question in the chat also if your mic is not working. Okay, so if there is no question, yeah.
So I have a problem with downloading the DEM. Can you please repeat again or
Yes,
just?
so are you using the Open Topography site only?
Yes.
Okay, fine. So let me share my screen. So what is your study area or for which region you are downloading the data?
It's Chaliyar. It's a river view.
Okay, so how big that area is?
It's 1 second, sir.
Okay, what I will do, I will just show my screen. You just give me the direction, so I will go to that area.
I will check it.
So
It's a 2,933 kilometers, the entire basement.
okay, so we'll see how much area we can download from here at once. Okay, so I think it's in let's say we can. Do you know the coordinate, exact coordinate of that area?
Yes, yes.
Yeah, tell me. X mean X, I mean X max, Y max.
X mean 75.833.
So okay, Y mean
11.167.
167.
And X max is 76.5 degree.
Okay,
And Y max is 11.5 degree.
11.5.
5.
Okay, so yeah, this area is downloadable. So
Okay.
okay, so current selection area is approximately 2693.
No, the downloaded file is not in TIFF file. It is compressed to another
Okay,
one.
okay. Yeah, so I will show you. I will show you. Wait. Okay, so DM file. Then
Yes.
after you have to go down.
Email. Yes.
Email. This is optional. You can just click on the submit button also. Then okay. Meanwhile, this is getting downloaded. One person has asked which platform to use, QGIS or RGIS. So better like I use QGIS personally because it's a free of cost. We do not have to pay license fee. If you have license with you, you go with RGIS. There is no harm. Like most of them, like both of them are very similar. It's like if it's QGIS is open source and RGIS is commercial one. Otherwise, the thing which you are doing, both are similar. So I prefer QGIS because it's open source. That's it. Now see, this file is downloaded. Like this link came.
Yeah.
Now
Yes,
this is
star.gz. What is that?
star.gz. Okay, so they will not give you the full data file. Okay. Why? Because size is very high. Same thing which we started from this lecture. That data to reduce the data transmission time and to reduce the storage, they will give you the compressed file, and they are using this star.gz compression method. Now, what you have to do is you just
Extract
this thing. Okay, so I will just extract and keep it in one folder. First of all, I will put it in one folder. Okay, now I will right click and then I will click on extract all. Okay, in your system might be extraction thing might be different. You might have 7-zip or some other extraction way. So this is the extraction which I'm using directly, which is coming with the Windows. And then after you can click on extract. Okay. So once it is done, it will show me this file. This is a .tip file. Okay. And then after I will just drag and drop this file into my QGIS window. So then after I will do zoom to layer and I can see my file. Okay. Okay. So you just check once what problem you are doing. If it is still not get resolved, you can share your screen next time and we will get back to you.
Okay.
Okay. Yeah. Anything else? Anyone? Okay, then I think if there is no more question left, we can end this session. Okay, so thank you everyone for joining the session. I hope you all will join it in the next next session also. Okay, yeah. So thank you everyone. Bye bye. Thanks for
Thank
joining.
you, sir.